And good afternoon, everyone. Dwayne here. Welcome back to the Radical of Math. Today, a commentary on why you should not take advanced placement calculus in high school. Yeah, we're going after the sacred cow today, folks. And so let's revisit some early math education to current math education. And this actually came to me in the form of a YouTube short. So they had a 50s era calculus text and they had a current calculus text. And in the 50s era text, they got to the derivative on page 22. The current calculus text, page 126. And now therein lies the problem. Because we have refused to show rigor and to enforce standards and the fact that we do social promotion in our education system. When you add all that up, our students, especially when they're STEM oriented, they get to college and they can fake their way through the first part of calculus, so differential calculus. They can do that. They get to calculus 2, however, and that is when you start seeing the first culling of individuals that cannot hack a STEM major. And the reason for that is Calc 1 is much more algebra oriented. Calc 2, though, is not just algebra oriented, but you have to visualize in a very different way. It's not linear as calculus 1 is. If anything, there's times where it's iterative, there's times that it's pattern recognition, there's times where you just go, okay, I got to grind out integration by parts. And all of that stems from a very poor understanding of the mathematics they need. So I'm going to give you 4 reasons why you should skip advanced placement calculus in high school. So I've alluded to it just now. The first reason is you have a very weak Algebra 2 curricula. That in turn lends itself to a pre-calculus curricula that is not up to standard, especially if you use the AP pre-calculus curricula, which I have spoken about before on the channel. Now, here in Kentucky, they break it out to pre-calculus. There's what they call an Algebra 3 and Trig, which I think is their version of what I took back in the day, which was analytic geometry and trig, and then AP stats in the junior year for like your advanced math, and then there's an algebra 2 bit for everybody else. But nevertheless, when you don't have a strong algebra 2, you're getting yourself into situations in certain parts of the United States where you sit down in front of an advanced placement pre-calculus text, and the first thing they tell you is, oh, module 4 you can skip. Well, that's polar coordinates. And now you're condemning that student to not be exposed to polar coordinates until calculus 2, maybe calculus 3. And polar chords, complex numbers, De Moivre's theorem, working back and forth with the whole concept of cis, so cosine theta plus I sine theta, and things of that nature, you are really hurting the student. I would consider it irresponsible to not expose those students in the junior year and include that as part of their trigonometry studies. So here is the consequence of basically having a weak Algebra 2, an advanced placement pre-calc that's really Algebra 3. You now get to calculus from the AP side, and now it's no more than a survey course. And you're spending a fair bit of time on limit. And to a student, you should be covering limit as early as possible. Right now in AP Pre-Calc, you're seeing a lot of discussions about, okay, are functions decreasing, increasing, what's the maxima minima? And those are calculus concepts more than they are pre-calculus concepts, because students don't have all the tools, and so now they break out a graphing calculator and it plots it and it goes, oh, here is your local minimum, here's your local maximum in many cases. Calculus is not a survey course. Calculus is a foundational course for STEM majors. And so now what's happening is if you have, most of your STEM majors are likely taking physics, especially if you're engineers, you're definitely taking physics. Computer science, stuff of that nature, you're taking physics. Now you're expecting the student to be able to function when you start getting into the integral part of physics, like work calculations and other areas thereof. Calculus being a foundational course means that if you take it in high school as a survey course, it leads directly to the fact that textbooks are spending a lot of time with remedial mathematics to get the student ready to take a survey calculus course. So, if you're spending 120 pages to talk about the definition of a derivative, and you're spending a fair amount of time discussing limit, when you can discuss limit in pre-calculus from the view of a vertical or horizontal asymptote, and actually start drawing the triangle, you don't have to get into the epsilon delta definition. Give them an easily accessible definition when you start drawing the slope of the tangent line and you start getting closer and closer and closer. So the textbooks are not good enough. They don't have the rigor needed, and the textbook writers know this. They want the credit for being calculus oriented, but at the same time, they've written to their target demographic. Now, here's the snag in all this. A lot of the calculus books you have in advanced placement calculus, you see in Calc 1 on college. So there's a very strong argument for not treating calculus as a survey course. Once again, it's foundational. Part of this is because you figure students have maybe 150 days to learn a material, and be thankful if it's only AB. Because if you're trying to do BC, you have power series, Taylor-Maclaurin theories. You do have some polar. When I took the exam in the 90s, I had a polar question. And because I did mu alpha theta and all that, I was like, oh, I know that. It's its area of a sector, bing, 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 and oh, here's how it translates, happy days. So for advanced placement AB, you don't even get to power series, I don't think, anymore. I know I didn't. And so now it's a very slow paced course, and it's not much different than brief calculus. And really the only difference between the two is one talks about limit and one does not talk about limit. That's it. So that leads to what I would consider to be kind of the crux of my argument, and that is in high school, for STEM majors, calculus is not as important as other subjects. You need linear algebra, like elementary linear algebra. I think it's a first or second edition of Elementary Linear Algebra by Edwards and Larson. It's a fantastic text for advanced high school math students, because if you give them the understanding of matrices and determinants and eigenvectors and values and all that, you have well prepared them when they take college level linear algebra to do quite well. So in my mind, you got to have a linear algebra element at the high school level. You need discrete math at a high school level. Get students dealing with modular arithmetic and number theory. Modular arithmetic is one of the foundations of encryption. You just take very large prime numbers, and you're doing modular arithmetic. Discuss clock arithmetic as the entry to that. The students need discrete math. For sure, need discrete math. They need to know, about tree diagrams. And then statistics. Taking a stats course that is non-calculus, which they exist. If you go to college curricula, they will have a non-calc version and a calc version of stats, 9 times out of 10. So have your kids start learning data analysis because it teaches them critical thinking. They'll be able to look at a data plot and go, why is this outlier here when the linear regression's this? Very, very good course. So now when you get to the university, the students already have a good breadth of mathematic know-how. It makes their 1 and 200 level classes easier to manage. I think what educators especially, but parents need to remember is some of these majors have a very high credit hour. When I graduated with my bachelor's in math, it was 136. I think that's right, 136 hours. There are some majors out there in the STEM field, 144. That's a lot of credit hours when you sit and you think about it. Because you figure for 8 semesters, you're looking at you're looking at 18 credit hours a semester to hit 144? Yeah. So that means that student's probably doing summer stuff. Then in some of these fields, they need internships. And I think you're asking way too much of students when they don't have the necessary foundation to cope. Because keep in mind, in the first semester in college, you have all the prereqs you have to fill. And so let's say going into math, right? I want to say it was University of Kentucky, but I may be wrong because I've been looking at so many different college curriculas. But from what I can vaguely remember in general, I'll say it this way, it's better. The expected load of that student is a minimum 15 credit hours. So what does 15 credit hours look like? So in most STEM fields, you need 2 semesters of science, and most of those curriculums are 4 credit hours. And so you have 3 for lecture, and then you have the lab. Okay. Then you have your Calc 1 course. And in a lot of universities, Calc 1 is not 3 credit hours because there's multiple lectures a week. And then you have your tutorial where you do your problem sets. So that's 5 credit hours. So you're already at 9 credit hours. And you still need to take your prereqs. So let's say you get, let's say your basic English class. So there's 3. You likely need like a history class or something like that. That's another 3. And now you have 4 classes. You're already at 15 hours. If you do that all the way through for your 8 semesters for your bachelor's, you're at 120 credit hours. And that's often not enough. It's often not enough. So students now are forced to take a 6th or a 5th class, depending on how they do it. And it's no wonder that you see AI usage all over the place. It's no wonder that students are looking for every shortcut that they can have because the course load is too much. So we have to prepare them early, give them a better math background. Now the jump to Calculus 1 at the university level is not steep. It's much more like this. It's more of a ramp. And so that leads me to the final point, and that is I think calculus is better taught in a university setting. So when I took Calc 1, it was a 5 credit hour course. Every day we were doing calculus. Monday, Wednesday, Friday were the lecture. Tuesday, Thursday was the problem sets. Now, in comparison, in many advanced placement calculus courses, the teacher will say, okay, do from this problem to this problem. It's the odd problems because the answers are in the back. And they're not even checking to determine whether you've done the homework in the first place. And then for the unit test, they're just doing multiple choice. There's not many free response questions until much further along in the semester and or calendar year. So at the university, because of those tutorials and problem sets, the student is going to end up having a much better overall understanding of calculus because it's no longer a survey course. It's a proper rigorous course that in many STEM fields, especially engineering, math, a lot of tech-oriented stuff. Now when you get to Calc 2, your culling rate, your churn rate drops significantly. It's gotten to the point where there are universities out there that go, oh, you took AB calculus, well, you didn't get a 5. You got a 4 and good on you, but you didn't get a 5. You're retaking the first calc class they offer. Like it's the classic. It's almost the academic version of participation award. That's how some universities are treating this right now. Only if you get a 5, like on the BC. Yes, some schools that are like more liberal arts, smaller schools, they'll let you go straight to Calc 3. When I took it, I made a 5 in BC. And so a lot of the state schools, if I had gone the state school route, I went in the military instead, I would have been able to skip both semesters of Calc 2. And what would have happened is I got into Calc 3, which is vector calculus at the time. And then a Calc 4 was more of multivariate calculus. And I would have been okay because I was really good at math and I was staying active, and I would have had 3 months to prepare for Calc 3. So I would have had any of my deficiencies covered. A lot of your high school students, they don't have time for that. Because put yourself in their shoes. They are having to do standardized testing. They're trying to max out for that, so they're going to have time for that. Then they're going to have all of their ECs, extracurriculars. Then they got to get really good grades. Where do they have time? Where do they have time? And so this is where we need to have some common sense. And so to me, I think AP Calculus, as there's no mechanism provided in the course for a pretest. You get students that get in there and their algebra and pre-calculus scores may say, oh, they made B's, but their proficiency is not good enough. And there's no mechanism. It's often based on the student going, I don't think I can do this. There needs to be a screening protocol, and there's not. So in conclusion, calculus is a great subject. It is a necessary subject. Calculus is the mathematics of the physical world. It is that important. Wait on it. It's going to serve you in better stead, especially if you take high school physics. Instead, look for other alternatives as they present themselves. If you got to take a dual enrollment class at the community college to get out of calculus, do it. The curricula is just not good enough anymore. And there's so many structural weaknesses that the students are not ready for, in the STEM field, for the onslaught of math that they will have to do. So those are my thoughts on AP Calculus. Not a good decision in high school, I feel. So as always, thank you for your support. Like, follow, subscribe. Cannot wait to hear from you in the comments about this one. As always, take care of yourselves, take care of one another. God bless. We'll see you next time. Bye for now.